Hello. Today we're looking at the FX9750G3 graphing calculator from Casio. I'm using the emulator right now, and the focus of this video is to show you how to use dynamic graphing, which is one of the menu options. So you'll see here in front of me the menu. This is the main menu, and you can scroll down through it to get to the different apps that you're looking for. We are looking for dynamic graphing. So you'll see here it's number 6, or it says Dyna, and you'll see this little parabola here. So we're going to hit execute, and that opens it up. And actually, let me delete some of these things that are in here. Basically, it looks just like the graphing option, where you enter in a function. The difference being you can enter in variables for the numbers, where the coefficients, so that you can actually see dynamically how something might change. So let's say I want to look at a quadratic, a parabola, and the parent function is x squared, right? So I can enter a normal function, and that's going to graph as it normally would. But now I want to see what is the impact of the variable on that function. So let's just say we, instead of a 1 in front of the x squared, what happens if I put an a, or whatever variable I want. So let's put an a here. So I'm going to do alpha a, and then I'm going to enter my x squared. So I've changed this slightly than the norm, because now I have a variable, something I can change, instead of the 1 that is here now. So notice I have some options down here. I can delete them. I can look at, let's look at type. I can change the type of graph, so you can do r equals parameter, those types of things. Let's hit exit, get back. I can change the variable, and this is where I'm going to talk about how I want to set this variable to start. So where do I want it to start? Well, maybe I probably want it to start at 1, right? So let's set this up, and I want it to start at, well, actually, let's look at some negatives. Let's make it -5 to 5, going by 1s. We could go by 0.5s. We could go by whatever we want. So this all looks good. And then I can even change the speed. So notice that when I go into set and type of variables, I can change that dynamic variable, how it's going to look when we're looking at it. So if I hit speed, notice that you can do a stop and go, and that means you're going to be able to control the movement. You can do slow, where it's going to move automatically slowly through. You can do normal or fast. So let's just look at normal just so you can see what it would look like normally. So notice that it's showing me the speed up here. The choice that I had is normal, and so we're okay. Let's hit exit. So now I've set up where I want the variable to scroll through, the values, the speed, and now I can look at it. So the difference here, and it's setting up basically the animation, here's my parent function, right? And so I'm trying to help students see, what does this variable, this coefficient a, do to the function. So when it's 0, I don't even see the function. When it's 1, it lands on top of the function. So notice that this is scrolling through. What's that a coefficient doing? When it's 1, it's exactly on top. When it's 0, I don't have anything, which makes sense because I don't have a function. And so now I'm able to dynamically see these changes in that coefficient, that variable a, and I can now realize that that determines how wide my parabola is, whether it's opening up or down. When it's negative, it seemed to be opening down. So I can get a lot of information just from watching this variable dynamically change. So as it's changing, I'm seeing the changes in the graph compared to the parent function. Let's hit, to get out of this, you hit all clear, and that will get you back to the last window that you were at. Let's go back here and show you the difference between stop and go versus these other speeds. Stop and go allows you to control it a little bit more. So I'm going to choose F1 this time. So we have stop and go, and exit out and hit the graph again. And what I want you to notice is it doesn't do anything because it's in stop and go mode. I'm going to have to change it myself. And to do that, you're going to hit the, it's execute. You hit execute. And so it'll move it based on your thing. So it's going to move it one at a time, or however you determine the step to be. So what are the students noticing? Now I can go a little slower, right? So when it's negative, it's all down, right? The parabola is pointing in the downward direction. And I can move it and kind of see when it was 1, I can see that it was right on top of the parent function, which makes sense. X squared is the same as 1 times x squared. And so you can control it that way by using the speed. I did want to also point out, so let's go all the way back. And so let's go back up to this. I chose a variable. I could have chosen any alphabet letter, but I wanted to point out here that there are also some built-ins. So that's what this BN means, built-in. So if I click the built-ins, notice that you can have it already in different forms of different equations and change your own. So let's choose the standard form of a quadratic this time, where I have 3 coefficients. So when I hit execute, that's already done for me. I didn't have to type that in. And then I'm happy with that. But notice now I can change each one of these. Well, we already figured out with what A does, right? It opens my parabola up or down, widens it. So let's change that to a 1. And so you enter the value you want it to start at, basically. And let's play with B, right? So B is going to be our current value. And let's leave C at maybe 1, or we could make it 0 if we want, because we really want to focus on what's B doing. And now we're still going to go to setup. And we want to change, oops, let's hit exit, sorry about that. I forgot to hit select. So it's automatically defaulting to the variable A. I need to change that by selecting B. So notice I have highlighted B. I'm going to hit F1, and now B, and you'll see up here, is my variable that I'm changing. Let's set up how we want it to run through, and I'm okay with -5 to 5 again. Maybe let's make this 0.5. So you can change the steps as well. Hit execute when you're set, hit exit. Speed, we're going to keep as stop and go. I like stop and go because I can control it. And then let's hit F6 to see what's happening. So remember, this time B is changing. A we kept at the parent function because we already kind of figured out what A is doing. So what is B doing? So here's that parent function again, x squared, and B's at -5. So it's off-centered here, right? So we are, remember, controlling it by stop and go. So as I move, it's bringing it back. So when B is 0, I'm sitting right on top of my parent function. So now students can explore what is going on with B. What is B doing to my parabola? And this is the beauty of dynamic graphing. You can change and look at different variables, coefficients, and kind of really get a sense for them and help students discover what each is doing, so that when they are given an equation, they can already have a sense of whether it's opening up or down, whether it's to the right, to the left, whether it's vertically up, vertically down, those types of things. So dynamic graphing is a great way to explore and help students discover connections.